Okay, Zaid, your school had started on 29th. That's why. Okay, that's why you're updated. Fine, class. So yes, definitely. As I've mentioned earlier, also revision classes will be happening. Revision we'll have in the class within itself because revision is required. Revision, numericals, test, and all these will be increased now. So at least till AC, your syllabus has been smooth. So now we'll be doing EM based, but along with it, we'll be having tests and numericals also. And again, I think 7 September is your test, your batch's test. Power and energy. Power is a simple topic. Just a derivation of power can be asked. Instantaneous power is usually asked. Instantaneous power. Now, from earlier knowledge, power is equal to voltage into current, VI. So here we can write this as EMF multiplied by the current. What was the value of E naught and I naught? If you put in those values, actually, this is E. If you put in the value of E, specifically E, this becomes what? This is E naught, fine, sine omega t. And I naught sine omega t minus phi. Both are getting multiplied. From here, just remember this step. This is the starting step for the power. Now, if you remember this step, then your answer the calculation becomes easy. Just put E naught and I naught together. Just put these two, I naught and E naught together. So what will happen? I naught E naught sine omega t dot multiplied by sine omega t minus 5. So sine is actually getting multiplied 2 times. So it's better if I write it as 2 sine omega t. Just leave omega t minus 5 aside. It can be, or do one thing. It's better if you do one thing. Multiply and divide the denominator by 2. This much we all can do because that won't affect if I multiply and divide by 2. Why are we doing that? To make an identity, because here we are not forming any identity. How will we solve this when we'll get this values? So what we do to simplify it, if I multiply and divide, so dividing here, multiplying here, this is what? 2 sine omega t sine omega t minus 5. And phi is what? What is phi actually?
An angle.
Phase angle.
Phase angle.
Yes, phase angle. That's why we say phi is 0 in case of circuit having only resistor. And please, class, whenever you are revising AC, try to revise this first, which is leading what is lagging behind for individual circuits. Combine it, LCR is done. Separate, make 2 combinations for RC and LR, that is also done. So that's why just understanding those simple circuits is very important. Now, one identity is here. Mathematics students must be aware. 2 sine A multiplied by sine B. Anyone has any idea?
Cos A plus B?
Cos A minus B minus cos A plus B. This is actually cos A minus B minus cos A plus B. This is the identity. So let's put, this is the same, 2 sine A multiplied by sine B. So we can directly write this. This becomes what? This is now that above can be written as E naught, I naught by 2 will be the same. E naught, I naught divided by 2. We are not disturbing this. Now only the above 2 in the numerator got utilized. So here we can write it as cos phi minus cos 2 omega t minus phi. If you open the brackets, 2 omega t will be there. Omega t minus omega t, that will be 2 omega t. This much is done. Now, see, average power dissipated we are calculating. That was this is the instantaneous power. Just in case in your exam, if instantaneous power is asked, leave your answer till here. But in your exam, instantaneous power won't be asked. Instantaneous, instead of instantaneous power, we maximum have the average power dissipated per cycle. So average power If you calculate, you have to calculate the average power of it. So average power of this will be what? Average, you have to take the average of what? Average power means average of this whole term, E naught I naught by 2 into cos phi minus cos 2 omega t plus phi. Average of this term. This you have to find out. See, for second cosine term, no, second cosine terms means cos 2 times some angle. That is known as second cosine. So for second cosine for an average over a cycle, if you want to find out the average, no need to go into the details. Nobody will be asking you why are you writing 2 cosine as 0 or something. Just remember, math section, that you have to give the explanation. In physics, at your level, you just have to remember certain things, like certain identities you have to remember. You need not derive this identity, you just need to learn certain identities. Similarly here also, second cosine term. What is second cosine term? Second cosine terms means cos 2 omega t minus phi. This is minus 1, second class. This term is minus. This term, this is what? This is 0. Is 0. Fine. But for what? For an average cycle over a certain period of time, for an average cycle, this term is 0. So if this term is 0, what's the average power that you will get? See, average power that you will get will be I naught is left, E naught is there, divided by 2, and only cos phi is left. What is root 2 multiplied by root 2 class? 2. So I can write 2 as this 2, I can write it as root 2 multiplied by root 2. I naught by root 2 is what?
Ma'am, IRMS?
IRMS, perfect. So this I naught by root 2, if you look over here, I naught divided by root 2. This is actually the peak, 1 by root 2 times the peak value, means this is the IRMS. And similarly, here if you look, E naught divided by root 2, this will be the ERMS. ERMS cos phi, that is the average power. This much was required from all of you. Fine, so average power derivation comes in exam. This much comes. Second cosine term and all these terms, second cosine terms and this identity, you can just write in bracket, no need to give explanation for that. But these other steps which are included in your physics, like I naught by root 2 is IRMS, all these terms mention it separately. Fine, note it down. Certain special cases we'll do for all the circuits we had seen. See, 4 conclusions from here that will help your questions become easier. For purely resistive circuit, phase difference between the current and the voltage is nothing. It's zero. You do not have the value of the phase difference between them. So what happens in that case, your phi becomes 0 degree because both are in the same phase. I and V both are in the same phase. So phase angle will be what? There won't be any phase angle. They are parallel to each other. They are in the same direction. So this will be 0. So what conclusion you can draw? For average power, you can write IRMS, ERMS cos 0 degree. So P average will be what? IRMS, ERMS, only this much into 1. Directly for a purely resistive circuit, you can even just use this much. Now, for purely capacitive or purely inductive, see, there what happened? Either current is leading or voltage is leading by 90 degrees. But even if any quantity is leading, a phase difference between them will be 90 degrees only. So your phase angle this time will be 90 degrees. So if you put P average as ERMS, IRMS cos 90 degree, whole term will become what? Whole term will become 0. So there is no average power dissipation in purely capacitive, purely inductive circuits. This comes in your theory questions only. This is not a part of your numerical question. These two. It can be asked directly. What's the power dissipated in an average cycle for purely capacitive circuit, purely inductive circuit? So this much you can mention. One thing, class, this current that we obtain in these circuits when the power is 0, that current is known as wattless current. So here you get the maximum current. Wattless current. Wattless current means what? When the current in AC circuit is wattless, if you say the average power consumed in the circuit is, if your average power is coming out to be 0, like in this case, for purely capacitive, for purely inductive circuit, your average power came out to be 0. So the type of AC that you'll obtain, AC is what? Alternating current, that will be known as wattless current. So this is known as wattless current. This is known as wattless current. So the AC, the alternating current, which is obtained when average power through AC circuit is 0. So this can come in your 1 marker. What is the wattless current? Or what is the power in wattless current? So do not calculate anything. Do not write the formula. It's 0. One more thing, one more term that I'll discuss, power factor. Power factor is just cos phi. Remember cos phi we used to write as R by Z everywhere. So here in the formula of average power, are you able to observe this? ERMS, IRMS, cos phi. So this cos phi is actually nothing but we call it as power factor. So certain terms were left to discuss. So power factor is basically cos phi. Note down this as well. Class, just check into your notes of electromagnetic induction. Did we do that energy for an inductor, half Li square? Just check and let me know, have we done that or not? Okay, sir. Thank you. Now, see, to prove this, that average power dissipated across this inductor and capacitor, this is zero. This can be asked in your exam. It's a very small derivation. Let's not skip it. Let's do it. See, energy associated with an inductor, purely inductive circuit, is the same that we have studied. Across inductor, this is half Li square. And across capacitor, it is half C square. Half CV square, half Q square by C, or half CV square, everything that we have studied in potential lesson. Fine, these are there. But it can be asked to prove that average power dissipated is zero. So one only I'll tell, because the other is just exactly opposite. So if any of this comes, you can write in your exam. So to prove that average power is zero, see, let's take the example for pure capacitor. So for pure capacitor, E will be equal to E naught sine omega t. Here current leads in case of capacitor. So this becomes I naught sine omega t plus pi by 2. Fine, I naught sine omega t plus pi by 2. Or I can write this as I naught cos omega t. So this is E naught sine omega t. This is I naught cos omega t. Now, for the work done is what? Work done is basically V naught into I naught. Not V naught, let's take it E naught. Work done is what? Work done is E naught, I naught, means E into I. So this becomes what? E naught is associated with sine omega t, and this is associated with cos omega t dt, because we have to integrate it to find the work done. So work done will be what? E naught, I naught will be there. And this is what? This is sine omega t, cos omega t. So this is E naught, I naught. Here you will be having 2, and this becomes sine 2 omega t dt. This is what we are left with. Now you have the work done. What is the relation between work done and power? Yes, class. Relation between work done.
Directly proportional.
No, the formula. How do you relate it? What's the formula?
Equal to W by T.
W by T. Perfect. This is power is work done divided by time. So let's say this is dW. Let's say this is dW. So if you have 1 by T over here, this will still be what? This will be integration of W from 0 to T, because obviously we have not integrated this side yet, just written this. So for integration, let's write the value of dW. So power becomes 1 by T is left here. This will be E naught, I naught divided by 2, and integration 0 to T. So sine 2 omega T will be left. Sine 2 omega T dt, this much will be left. Now class, when we integrate sine theta, we'll get a negative sign. This is E naught, I naught by 2t. We'll have a negative sign. Cos 2 omega t will be here, as well as 2 omega will go down also in the denominator. This is in limits from 0 to t. Now what is left? Okay, substitution of the power is left. Let's take 2 omega here only. So this becomes 4 omega t. So minus E naught, I naught by 4 omega t. Just I have multiplied this here and this negative sign outside. Now what is left from here? Cos 2 omega t into t minus cos, I'll write it out. Cos 2 omega into capital T minus cos 2 into basically 0, or cos into 0 only. This is written as what? Cos 2 omega t, and if you write this, this will be 0 only, minus cos 0. So what is left? E naught, I naught, minus E naught, I naught, 4 omega t is left. Here you can write this as cos 2 pi. Omega and time period, remember this is 2 pi by t. This we have been using a lot. So this becomes 2 pi by t minus cos. So here you have E naught I naught by 4 omega t cos 4 pi minus cos 0. Cos 4 pi is 1, cos 0 is also 1. So you have minus E naught I naught 4 omega t 1 minus 1, which cancels, and this is 0. So your average power is 0. Now this we had taken for pure capacitor. That's why in the starting we had taken these two lines. E naught as E as E naught sin omega t and I as I naught sin omega t. If it was a capacitor, nothing different. If it was just an inductor, nothing difference will come. Here you will be having a negative sign because this will be minus pi by 2 then. Just negative sign, ultimately cos minus pi by 2 will give you the same answer. When you will derive derivation, ultimately you will be left with same thing only. So it's just the same derivation. So if the question comes to prove or derive the expression, or it can be asked, prove that an ideal inductor connected to an AC source does not dissipate any power. Like these question can be asked in the exam. So write down all these points if it's asked. Yes, first part is right, Zed. So a light bulb is rated at 100 watt for 220 volts. So this 100 watt is the average power. This is given as 100 watt. And this is obviously the ERMS 220. Firstly, it is asking the peak value of the source. Peak value is E naught, which is root 2 times the ERMS. So all the previous concept only got utilized. This will be 1.414 into 2. So this will be approx 311 volts. Your answer was right, sir. Now for the resistance of the bulb, any answer? Resistance is 484. Yes, resistance, correct. See, for the second part, power, power is what? If you relate power and resistance, this will actually be PV square divided by R. In current electricity, we had seen this formula. Remember in the last, when we ended the lesson, current electricity, we had seen this formula. So R will be equal to what? Here in AC, this will be VRMS divided by power will be the average power. So VRMS square is 220 whole square, average power is 100. So this will be what? 220 square, 22 square. Okay, so 480. Last is current, RMS current. Okay, so resistance, even you can calculate it with the help of power. See, power is equal to VI. So current here will be equal to what? Average power divided by the RMS value. Average power is 100. This is 220, right? 0 will get cancelled. 5 by 11. So 0.4 0.4545. All right, so 0.45. This much will be the correct. All right, class, noted down. In your syllabus, LC oscillations are included, no? This time as well. Zed, in your school? Done, class?
Yes.
So, see, I'll stop here. I'll not teach further. Transformer is left that we have to do, and LC oscillations are left. AC generator we have already done in the starting. So transformers, LC oscillations, that I'll do on Monday only. Before these topics, before transformer and LC oscillations, that will be included on 7th. Though this will be completed before 7th, but still you will not be having sufficient time to revise it, or lesser questions will be there from these topics. But apart from this, on Monday only, after completing transformer and completion of this LC oscillations,